Hi everyone, we are from Lab S1G1 Group 1 and today we will be presenting our project titled Smart Cafeteria Rating System. Our team members are Eugene Hao, Chi Fang Yi, me, Wang Man Yi, Lim Jiahui, Sun Bong Ming, and Thi Kai En. Together, we have worked on building a system that can better evaluate cafeteria service quality and handle uncertainty in customer feedback. So let's get started by looking at the problem we identify and how our solution aims to address them. In food service, there are several common issues that customers often face. These include inconsistent food quality, slow service during peak hours, limited menu variety, and even poor cleanliness. All of these factors directly affect customer satisfaction. But beyond this visible issue, there's a bigger challenge, which is uncertainty. Customer feedback is often subjective, with comments like the food is slightly good or the order service is not enough. Traditional systems that rely on simple if-else logic struggle to handle this kind of uncertainty. That's why we need a smarter approach to evaluate and improve service quality.
My name is Lim Jiahui, and I would like to present the objective of our Smart Cafeteria Rating System. Our objective is to design a hybrid fuzzy system by integrating the Mandani Fuzzy Inference System (FIS) with the Fuzzy Simin (FCM). The purpose is to evaluate the cafeteria quality from the customer reviews. The FCM automatically learns the membership function from the data, while the Mandani FIS uses the expert-defined rules to generate an interpretable cafeteria rating. The next one is the agentic AI module. Instead of only generating the recommendation, the agent continuously analyzes the fuzzy inference result, identify the unreasonable output or the weak performance aspect, and provide the intelligent recommendation to improve the reliability of the system. The third one is the support cafeteria decision making by converting the raw textual review into meaningful insight. This helps the cafeteria administrator identify the service issue and make the data-driven improvement. The last one is the back-end is developed using the Python Fast API and deployed on the render. The front-end dashboard will communicate with the back-end through the RESTful API that allowing the review to be processed automatically and the latest rating and recommendation to be displayed in real time.
I am Chi Fang Yi. Now I will explain the solution design for our system. Firstly, we collect text review in Google Form for 3 cafeterias. Then we use LLM to normalize or clean the sentence. After that, we use lexicon to extract the keywords and assign them to 4 aspects. Next, whether it's a pre-trained sentiment model, it will help us to give score or strength to the keyword. FCM will take all the reviews and do clustering. This will find out the actual peak of triangle in our membership functions. Each aspect will have one membership function. So when come to this stage, one review will produce one score vector like this. Since we have many vectors for one cafeteria, we take the average of the scores. This will produce one average score vector for one cafeteria. It will then be passed into the FIS stage, which is our knowledge base stage. The FIS will use the membership functions produced from FCM and fire the rules given by expert to combine the 4 aspects into one rating. Finally, we defuzify it to get a crisp rating output between 1.0 to 5.0.
Thank you, Chifangi. I'm Eugene Hao. I'll proceed to the agentic AI slide. So the agentic AI acts as an autonomous fuzzy tuning agent. While the fuzzy pipeline produces the ratings, the agent sits on top of it as an autonomous supervisor that monitors the system and adjusts membership functions only when abnormal behavior is detected. It also provides recommendations based on the weakest aspect identified in the analysis. It runs a 4-step loop. The first step is sense step. It detects a rating that looks wrongly low. Secondly, in the reason stage, a local LM, which is Olama, is used to identify which aspect is the likely culprit or problem. Next, in the act stage, it applies a small safe reversible adjustment to the aspect's membership functions, but only if a problem is actually found. Lastly, in the reflect stage, it rechecks the fix, which is done at the act stage, and the fix will be undo if the sanity checks fail. Next, I will explain on the experimental result. And before that, these results are mainly based on the back-end terminal interface. So here are the final results obtained after running the complete pipeline on 178 reviews collected from the three cafeterias. Overall, all three cafeterias received very similar ratings and were classified in the medium category. Cafeteria 2 and Lestari both achieved a rating of 3.14, while Satria scored slightly higher at 3.15 out of 5. Since the overall ratings are quite close, the aspect level analysis provides more meaningful insight. When we examine the four evaluation aspects, menu variety emerged as the strongest aspect across all cafeterias, indicating that students indicating that customers are generally satisfied with the range of food choices available. In contrast, service speed consistently received the lowest score, ranging from approximately from 0.429 to 0.513. Therefore, the main finding from our analysis is that while customers appreciate the variety of food options, service speed remains the most common area for improvement across all three cafeterias. Next, this slide shows the actual output generated by the agentic AI after analyzing the cafeteria ratings. The first part is the sense stage. Here, the agent evaluated the all average scenario and produced a rating of 2.87, which falls within the expected medium range. So since the result was reasonable, the agent determined that the membership functions were healthy and therefore no adjustment was required. This actually the desired behavior, as the agent is designed to intervene only when it detects an abnormal or suspicious rating rather than modifying the fuzzy system unnecessarily. Although no tuning was performed, the agent still generated recommendations for each cafeteria. For all three cafeterias, menu variety was identified as the strongest aspect, while service speed was identified as the weakest. Based on these findings, the agent recommended maintaining the current menu variety while focusing on imposing service speed, for example, by adding staff during peak hours or streamlining queue management. Overall, the results demonstrate the two roles of agentic AI. Firstly, as an autonomous supervisor that can safely adjust the fuzzy system when needed, and secondly, as a recommendation engine that provides practical guidance for cafeteria management. Thank you. My group mate T. Kai will proceed to the performance evaluation part.
For performance evaluation, we use two metrics here, coverage and fuzzy partition coefficient, or FPC. Coverage measures how many reviews actually contributes a score for each aspect. Food quality and service speed both hit 93%, while cleanliness and menu variety came in at 87 and 84%. The lower menu variety coverage simply means fewer people commented on food choice, not a system failure. For FPC, values closer to 1 mean the FCM cluster are well separated and distinct. All four aspects score between 0.779 and 0.921, which with a mean of 0.86, which indicate our low, medium, and high cluster are clearly defined. Menu variety had the highest FPC at 0.921. Be more decisive, service speed had the lowest at 0.779, which is expected. Perception of wait time vary depending on queue length and time of the day. So this isn't a weakness, it reflects the nature of that aspect. Next, we validate the expert rule logic through phase validity sanity test. The idea is straightforward. We feed known input into the FIS and check whether the output matches common sense expectation. 4 out of 6 test cases passed. The all excellent cases correctly produced a high rating of 4.37 and all poor correctly gave a low of 1.6. The bad food Vedo case also passed, returning 1.62, which confirmed that Rule 16, our food or cleanliness Vedo rule, is working as intended. However, 2 cases failed, and they are worth explaining. For bad cleanliness, we expected a low rating, but the system returned a 2.85, which is a medium. Although the Vedo rules were triggered, the cleanliness score did not fully belong to the low membership set. So the strong positive contribution from the other aspect outweigh it. The second failure is good food, poor food variety, which rated 3.58, high instead of expected medium. This is because the rule-based reward strong food quality and cleanliness more than it penalized the weak menu variety. Both failures actually points to the same underlying behavior in fuzzy system. Strong aspects score can dominate over a single weak one. This is something we have identified for future improvement. Specifically, strengthening the value mechanism and adding rules that penalize low menu variety more heavily.
Hi, I'm Sun. Now I will be present about our project limitation. First, we have an input anomaly variability because our system cannot actively detect or block coordinated fake reveal spam. The next, we face LLM language drift as our small local 3B model can sometimes misinterpret complex local Malay terms. So for third, we have a lack of deterministic fallback. If the local LLM application goes offline, our raw unclean text can go straight to the vendor, which also risks causing scrolling errors. To fix the limitation for our future web, we plan to add 4 enhancements. First, we will deploy a review relevance agent to actively flag and quarantine spam reviews. Then second, we will add a temporal detector to automatically adjust fuzzy strictness during run slash or exam weeks. So for third, we will expand our dataset and lexicon with a local Slack backup dictionary. Then finally, we will utilize cloud scaling to upgrade to a larger model and expand our system across the entire campus cafeteria. And finally, to conclude our presentation, our project successfully fulfilled its core achievement. We built a functional pipeline that transformed noisy free text student review into interpreted 1 to 5-star ratings by integrating weather sentiment analysis, data-driven FCM clustering, and knowledge-driven Madani logic. Our ratings remains mathematically defensible. Furthermore, our custom agentic AI loops operate as a reliable internal safety net to prevent data anomalies for corrupting our system logic. So lastly, this framework delivers transparent, meaningful decision support for both campus consumer and university cafeteria management. That's all for us. Thank you very much.